In example number 2, we're writing an equation of an ellipse centered at a point other than the origin. So given the vertices and foci of an ellipse, not centered at the origin, we want to write its equation in standard form. Number 1, we have to determine whether the major axis is parallel to the x or the y axis. Now, if the y coordinates of the given vertices and the foci are the same, then the major axis is parallel to the x-axis. So we're going to use the standard form here. If the x-coordinates of the given vertices and foci are the same, then the major axis is parallel to the y-axis, and then we're going to use the following standard form. Step number 2, we need to identify the center of the ellipse, hk, using the midpoint formula, and then the given coordinates for the vertices. Step 3, we're going to find a squared by solving for the length of the major axis, 2a, which is the distance between the given vertices. Step 4, we're going to find c squared using h and k found in step 2, along with the given coordinates for the foci. Step 5, solve for b squared using the equation c squared equals a squared minus b squared. Step 6, we're going to substitute the values for h, k, a squared, and b squared into the standard form of the equation determined in step 1. So for example 2, it says, what is the standard form equation of the ellipse that has the vertices -2, -8, and -2, 2, and the foci -2, -7, and -2, 1. Now, the x-coordinates of the vertices and the foci are the same. They're both -2. So that means that the major axis is going to be parallel to the y-axis. So the equation of the ellipse will have the form x minus h squared over b squared plus y minus k squared over a squared, which is equal to 1. So now what we have to do is we need to identify the center, which is hk. And in order to do that, the center is halfway between the two vertices. The first vertices is -2, -8, and the second vertices is -2, 2. So we have to apply the midpoint formula to find h and k. So the values of the x-coordinates, okay, are going to be given by -2 plus -2 divided by 2, which gives us -2. And then -8 plus 2 for the y-coordinates, divide that by 2, which gives us -3. So now we know that it's centered at -2, -3. So we know h is going to be -2, and we know that k is going to equal -3. Now in step 3, we need to find a squared. Now the length of the major axis is 2a, and it is bounded by the vertices. So we solve for a by finding the distance between the y-coordinates of the vertices. So the distance, we have 2a, which is equal to the value of 2, which is the second y-coordinate, and then we're going to subtract the first y-coordinate, which is -8. Well, 2 minus a -8 is positive 10. Divide both sides by 2, now we know that a is equal to 5. And if we square both sides, now we know that a squared is going to equal 25. And now what we need to do is we need to find and solve for c. In order to do that, we have to find c squared, so the foci is given by the following, h and then k plus or minus c. So by looking at the coordinates that were given for the foci, we can say that h, k minus c is equal to -2, -7. So one of our formulas can be k minus c, which is the y-coordinate, is going to equal the other y-coordinate, which is -7. Or we can use the other form, which is h, k plus c, and we can set that equal to the other coordinates of the foci, which is -2, 1. Now since the y-coordinate is k plus c on the left, we can set it equal to the y-coordinate on the right, which is 1. So k plus c is equal to 1. Now we can solve for c because we determined that the center has a k value of -3. So we plug -3 in for k and then solve for c. So -3 plus c equals 1. Add 3 to both sides and c is equal to 4. If we square both sides, then c squared is equal to 16. Now it doesn't matter which one we choose to use, and I'm showing you both, but if we let k minus c equals -7, and again substitute k in to be -3, when we solve for c by adding 3 to both sides, we get -c equals -4, then we get c is equal to +4, which then again gives us c squared equals 16. So you can see that we're going to get the same answer. It doesn't matter which equations that you use. Now that we know c squared and a squared, then we can solve for b squared using the equation c squared equals a squared minus b squared. So c squared, which is 16, which is equal to a squared, which is 25, minus b squared. If we subtract 25 to both sides, we get negative 9. Divide both sides by a negative, b squared is equal to 9. And so now, in step number 6, we can substitute all the values that we found for h, k, a squared, and b squared into the standard form equation for the ellipse. So it's going to be h minus a negative 2 squared, which is 8x plus 2 squared, divided by b squared, which is 9, plus y minus a negative 3, which is y plus 3, squared, over a squared, which is 25, which is equal to 1.